Guys, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. Before you proceed, I kindly like to request our members to subscribe, engage us in the comment section, and also ring that notification bell so that we can be getting various updates on the different topics under discussion. Now, in this case, I'm going to put a link of other similar videos in the description box of this particular video, and they're going, of course, to play a fundamental role in trying to assist us comprehend the whole concept of statistics. Now, in this case, I'm going to look at the concept of types of measures of dispersion. In this case, particularly, we shall look at the concept of the quartile deviation. Now, the concept of a quartile deviation in some of our discussions is going to be given a term of a semi-interquartile range. And of course, I'm going to mention that one particularly using a specific example. Now, in our last discussion on the concept of quartiles, I mentioned that basically we're going to have different types of quartiles, which are constituted the concept of deciles, the quartiles, and the percentiles. And I'd said that given a group data, we can compute these various aspects of the measures of a central tendency by treating a specific distribution of such a kind of data using different procedures. And of course, in this case, we are going to consider this specific range of data given in terms of class and frequency. And of course, we are going to be required to find the cumulative frequency, which is going to be appearing in terms of particular values for these three ranges of measures of central tendency, which are given. And in this case, we are going to look at the concept of this particular aspect of the quartiles. And in particular, of course, it's going to be under the measures of dispersion, and therefore it's going to be a discussion on the concept of quartile deviation. Now, we can recall from our last discussion that basically for us to find the concept of a quartile, be given a general formula for us in trying to describe this specific aspect. And as I said, of course, a quartile is going to be a measure that divides the frequency distribution into 4 equal parts. And therefore, in that case, I said that we are going to have very specific types of quartiles given as the first quartile, the second quartile, and the third quartile given in that particular aspect. And generally, we can represent this particular aspect of a quartile, therefore, from this specific explanation of an ith quartile. And this, of course, is going to be implying the various range of numbers for I for the first, second, and the third quartile, as I had explained in my first video. Now, in this case, they said that basically for us to find the quartile, we're going to see that the first quartile given as Q1 is going to be equivalent to or greater than 25% of that specific distribution. And in that particular respect, of course, others are going to follow given that specific ratios for the percentage of 50 and 75 for the second and third quartile given as such. Now we can be able to identify the ith quartile, which I've given in this particular case as Qi, using this specific ratio of In divided by 4 in that particular case. And I mentioned that basically a quartile is going to divide a specific range of data into 4 equal parts given as such. So for us to find a quartile for a group data like the one that I've given on the board, we had given a specific formula which of course is going to represent a general case for finding the ith quartile, whereby we said that for us to find the ith quartile, this is going to be given as the lower class boundary of the quartile class given as LQI, and then we are going to have that one of course added to the ratio between the class size given as W and the frequency of the quartile class, the ith quartile class given as such, and this is going to be multiplied with the value of In over 4, which basically I've given below, minus the cumulative frequency of that, of course, class that precedes the quartile class. And this is going to be considered for the less than type of frequency, which I've of course mentioned in my frequency distribution table in my previous video. Now, in this case, this can give us a general formula for finding the various types of quartiles. And from the distribution which I've given above, of course, we're going to see how we can derive various types of quartile from that particular case. Now, this is going to assist us define the concept of quartile deviation. which basically is going to be also a ratio or a particular difference between the third and the first quartile of a set of items. And of course, that's going to be the average over that particular difference. Now, in this case, this is going to be giving us the concept of the semi-interquartile range, which defined. Now, for us to find the quartile deviation from this concept of a quartile, I've said that we're going to have the first, second, and third quartile. Now, the interquartile range, I've mentioned the interquartile range. We have said the range is the difference between the largest and the smallest value. And for these quartiles, we are going to see that, of course, the difference between the largest and the smallest quartiles given as Q3 minus Q1 is going to give us the interquartile range, which is the third quartile minus the second quartile. And of course, I've mentioned the concept of the semi-interquartile range. The semi-interquartile range. Now, this is going to be basically refers to the half that specific quantity. So therefore, the semi-interquartile range is going to be given in terms of the average of this interquartile range given as Q3 minus Q1 divided by 2 given as such. And of course, in case I mentioned the concept of therefore the interquartile range is the difference between the two. The semi-interquartile range is this specific interquartile range divided by 2 given as such. Now, of course, we are going to also look at the concept of the coefficients of quartile deviation, which is going to give us, of course, an average amount of this difference between the interquartile range and, of course, the sum of these two specific ranges for the upper and the lower quartile given as such. And I'm going to elaborate on that one, of course, in my next discussion, as we're going to see from the previous or from the specific tables which I'm going to give on the board. Now, perhaps since I've mentioned the two specific concepts of the semi-interquartile and the quartile range, therefore I can just summarize this one for the coefficiency or the coefficient of a quartile deviation. So that in case I mention it, then therefore it's going to be elaborate for us. So basically this is going to be initialized as the coefficients of quartile deviation, and this is going to be the ratio of Q3 minus Q1, and this is going to be the average value for this. So therefore this is going to be divided by 2 all over the sum of Q3 plus Q1 divided by 2 still given as such. So basically this is going to give us the difference between the third quartile and the first quartile, and the sum of those specific quartiles Q3 plus Q1 given as such, and that's going to give us the coefficients of a quartile deviation. Now this is going to give the average amount by which the two quartiles are going to differ. And of course, we're going to look at that one in a specific example using the particular distribution which are basically given on the board. Now, in our previous discussion, I had basically mentioned that given a distribution table of this specific kind, we can compute what we refer to as the cumulative frequency. And in this case, from this particular formula, of course, I had mentioned the concept of a cumulative frequency of the class preceding the quartile, or rather that specific quartile class, and therefore it will be okay for us to find a specific range of values for the cumulative frequency in this case, which is going to assist us evaluate the quartile deviation in this particular case. So I'm going to have that specific set of values, which are going to include the cumulative frequency. Now, from the above, we can use this specific set of the less than type kind of frequency, of course, in trying to evaluate the various types of quartiles for the first, second, and the third quartiles for this specific set of data, so that they can assist us, of course, find the various values for the first, second, and the third, so that we can use those specific values to evaluate the quartile deviation, which I've mentioned, or the interquartile range, which I've mentioned in that specific order. Now, I've said that basically for us to find these particular values, I'm going to have this one, an elaboration of this one, perhaps to remind us of the various values that we're going to attach to this particular formula. I'd say that this basically the lower class boundary of the quartile class is going to be given in terms of LQI, and of course the W represents the class, size of that specific quartile class. And as we're going to see, this is going to be the difference between this upper and lower class limit, of course, which is going to be a consistent value of 10. And as we are going to see, the frequency of the ith class is going to be considered in case we identify a particular value, as we're going to see later. Now, this is going to be the value for the which are the given, and of course, minus the cumulative frequency of that specific value of the class preceding the qith class, as we're going to see later. Now, I'm going to put a link of this specific video in our description box, so that in case we need to follow up it for further clarification, then it's going to assist us in trying to find that specific evaluation on various types of quartiles. But I'm going to give this one in summary form. Now, in this case, for the first quartile, I've said that we're going to have in over 4. Basically, then therefore, this is going to be given as n represents the total number of observations, which is basically the value of the total cumulative frequency. And this is going to be given as 493 all over 4, given as such. So this one gave us the value of 123.25. And of course, this is going to be in relation to the cumulative frequency of this particular value, which we have, of course, given in this particular case for the values of 25% equivalent to or greater than. So for us to consider the cumulative frequency that is going to be having this particular value, it's going to be, of course, greater than 88, but falling within this specific range. So we're going to have a Q1 falling at this specific range. Therefore, the class of the first quartile for us is going to be a class of 170 to 180. And therefore, for us to identify the lower class limit of the value of LQ1, this is going to be given as 170, given as such. So remember, we have decided that this is going to be given as the lower class limit minus the value of the units of measurement. And in this case, there's no difference between the two. So we're going to have 170 as the lower class, of course, a boundary of that specific class. And then we're going to have the value of n, as I had said, as the total number of observations, given as 493, which is basically the sum of the cumulative frequency given as such. And then we shall have the cumulative frequency of the class preceding or the class before the first quartile class. And that is going to be, of course, the value of 8 given as such. And then we shall, of course, have found the values for that. And then we're going to find lastly the values of the frequency of this specific first quartile class, which of course is going to be 72, given this specific range for this particular class. And these are going to be the values being substituted in this particular formula, and they're going to assist us find the first quartile. So in this case, we shall have this 170 for LQI, so LQ1 in that case, plus W in this case is going to be the class size, which is going to be the difference between the upper and lower class limit. Of course, in this case, we had decided that we can evaluate the value for W as the ratio between range over class, and this is going to give us the value aside of this specific type by doing a roundup as a dimension. So basically, this is going to use this specific formula of the ratio between R and again finding the value of this specific W, and therefore that's going to assist us compute this. So we shall have this one given as 10 all over FQI is equivalent to 72, and then we shall have this specific value. We had basically evaluated it in this case, and this is going to give us the value of 123.25, and this is going to be minus the cumulative frequency of the frequency preceding the first quartile class given as 8. So this is going to give us the value of the first quartile, which is basically 174.90 given as such. So this is the procedure that we shall use for finding other types of quartiles for the first, second, and third quartiles in that particular case. And therefore I'm going just to list the figures for this first, second, and third quartiles, which are going to assist us, of course, evaluate the quartile deviation from a specific discussion. So I hope that we have understood from this specific recap how we can find the various types of quartiles. And so therefore I'm going to have the first quartile from my evaluation given in terms of 174.90. My second quartile, of course, from that specific evaluation, I got 190.23. So be clear, 190.23. And then I had my third quartile given in terms of 203.83. Now, from previous formula, of course, which are given for finding the quartile deviation, I said the quartile deviation is going to be the difference between Q1 minus Q3 all over 2. So from the above values, I'm going to do a substitution or a substitution for these particular values of 0.83 minus. So this Q3 minus Q1, 174.90. All this one divided by 2, and my quartile deviation basically is going to be 14.47. So the QD 14.47 given as such. So that's my first evaluation, and I can calculate the coefficient of the quartile deviation by finding this specific value. So I said that basically this can be given in terms of course, 2 times the quartile deviation all over Q3 plus Q1. So this is going to be the coefficients of quartile deviation. Just perhaps I can be more elaborate on this. We just have this space. So I'm going to have my coefficients of quartile deviation given in terms of 2 times the quartile deviation all over this Q3 plus Q1. So doing a substitution for these specific values for the sake of our space, of course, we have found the value for QD given as 14.47. So this is going to give us the value of 0.076. Kindly you can do an evaluation from that specific case and try to give us a feedback in case you find a different value. In this case, of course, we can see that of course these are going to be given as such for the quartile deviation and the coefficients of quartile deviation given in that particular case. And that's going to be, of course, a way in which we can evaluate this specific aspect given a set of distribution of data of this specific kind which I've given on the left. Now, in our subsequent videos, we're going to look at other types of measures of dispersion, and that's going to form a comprehensive part of various measures which we're going to come across in our various discussions on statistics. So that is it for now, guys. By God bless you. Catch us in our next video.